Okay, this is a review of some skills involved with quadratics. Okay, so here, notice guys, we have a typical quadratic in standard form. See how we have an x squared term, a 5x or x term, and of course a regular constant minus 2 term there, right? So whenever you see that, I hope you realize, now here was the directions, we are expected to factor this. Now notice we can't solve it unless there's a equals something, right? And that's something you guys somehow have got to understand. You can't solve unless there's an equal. Only thing we can do, again, in this case, is we're going to factor this expression here. Okay? So how do you do it? Well, you've been maybe taught different ways, but I'm just basically going to do FOIL method backwards. And what I mean by that is, see this 3x squared? I know it's got to be 3x times x, right? And see this minus 2 right there? It's got to be a 2 times 1. Now the only problem we have is it 2 times 1 or is it 1 times 2? Okay? So let's figure this out, and the best way, in my opinion, to do a problem like this is you just try it out. It's like trial and error. Guess and check. So let's say we use 2 times 1. Isn't the 2 going to times the x and give us 2x? Isn't this 1 going to times with that 3x and give us 3x? Now, can we get a 5x in the middle? And the answer is yes. I can add 2 there and add 3 with it. So does everybody agree 2 and 3 is 5x? But there's a problem here, because isn't 2 times 1 positive 2, and we have a negative 2 there? Oh no. So guess what? I guess that way didn't work, did it? So what are we going to do? Well, let's backtrack here. And instead of 2 times 1, let's try 1 times 2. Notice here I get a 1x. Here, 2 times 3 is 6x. Can I get this 5x in the middle? Again, yes. If I do a plus 6 minus 1, I get 5. So I'm going to put a minus here, so you can see right in here, I'm going to get a minus 1x. And I'm going to put a plus there, because 2, again, times 3 is going to give me that 6x. And again, 6 minus 1 is 5. This 6, let me use purple, this 6 minus 1 is 5, right? Okay, so, and finally, do you guys agree the negative 1, when it times with the positive 2, will give me negative 2? So long story short, 3x minus 1 times x plus 2 is the factored form for that given quadratic expression. So here's where you pause the video, guys, take notes, and make sure you understand. Okay, now look at this one. Notice how this one has an equals 0 on it. So even if I did not give you instructions, you should know that we're going to solve this one, right? So there's a couple ways we could solve it, but I wanted to take the opportunity to remind you that you can do something called GCF factoring, right? GCF, greatest common factor. So how are we going to do that? How are we going to do the GCF on this thing? Well, cleaning up here a little bit. Well, why don't we start with looking at the numbers 16 and 8, or 80, sorry. What can I divide them by? This can be a little tough and tricky, but I hope you realize that 16 times 5 is 80. Notice how they both have a t in them. One has a t squared, one has a t. So I'm going to take out a t as well. So this 16t right here, you see, is my greatest common factor, my GCF. So what do we have left? Well, does everybody agree that if I did a negative t here, what that's going to do is right here, 16t times negative t is negative 16t squared. And if I do a plus 5, well, follow the purple again. 5 times 16t is 80t. And long story short, 16t times negative t plus 5 equals 0. Okay? And what we did was take this expression that we initially were given, follow the green, that now is factored here. Okay? So now what? Well, it's just a simple question of what makes that, because after all, if that is a 0, when I do 0 times that, won't I get 0? So does everybody understand if t is 0, I will get a 0 for this problem? What about this right in here, though? Well, how do I make negative t plus 5 equal 0? I could go ahead and minus 5 both sides. And negative t will equal negative 5. And once I divide by a negative, isn't t equal to 5? So in conclusion, I now know that, follow the green to the right here, t could be 0 or t could equal positive 5. Again, pause the video, guys, and make sure you understand that. Okay, now here's another challenging problem I want to take a look at. Because my video is running long, however, I'm going to make a separate video on this, and this will be, of course, my review number 2 on quadratics. So until then, guys, please, again, rewind or replay the video, pause it, take notes, and if you have any questions on this, please ask me in class. Until then, bye.